Hi everybody, welcome to You Can Do Math. Today we're going to solve inequalities that have multiple steps. And I just really want to thank you for watching these videos and thank you for engaging and learning with me. All right guys, let's get started. All right everybody, so we have 3 examples for today in solving multi-step inequalities. I'm going to do the first 2, the third one is for you. Let's get started. All right, so I want to let you know that most students make this common error right away. They perform this operation. They'll do 7 minus 7 and they'll put a 0 here. Don't do it. Don't fall into that. Remember your order of operations. This 7 or negative 7, right, is distributing to each term, which means it's multiplying. And in the order of operations, we have to multiply first before we add or subtract. So that is a very common error. Don't fall into it. Let's go ahead and get started. Let's distribute that negative 7. Okay, so if we distribute the negative 7 to both terms, what I want you to do is I want you to write down everything else that we haven't touched. And I know that seems tedious, but it's really important to keep yourself organized because when there's multiple steps, you don't want to lose a part of the equation. So you do want to keep writing it down and bringing it down. It's really important to stay organized. Okay, so then we have negative 7x and then a plus 56. Now, from there, you need to look and see if you can combine like terms on either side of this inequality, right? So is there anything here that we can combine? Are there any like terms? And there is. We have a positive 7 and a positive 56. So you have to combine both of those first before we start manipulating our equation to solve for x. So then, if that's the case, we're writing the 84 and the inequality sign again, and then we have negative 7x, and it's going to be a plus 63. All right, so that order doesn't matter. You could have put the 63 minus the 7x. I just usually like to write the variable first and then the constant next. All right, so now let's go ahead and solve for x. So we're just gonna subtract the 63 to the other side, and 84 minus 63 gives us 21, and that is still greater than a negative 7x. Then let's go ahead and divide by negative 7, and when we do that, don't forget that inequality does flip when we multiply or divide by a negative. So our x now is going to be greater than a negative 3. For those of you who like to write it where the x is on the left-hand side, we're going to have x is greater than negative 3, and both of those answers, remember, are acceptable, right? They mean they're the exact same thing. They're just written differently. And so then now we're going to draw our number line, and we're going to put negative 3 in the center. Let's represent one value on each side. Negative 2 to the right, we're getting greater, and then negative 4 to the left because we're getting smaller. And this is an open circle, right? Open circle at negative 3. And since x is everything larger than negative 3, we would like to shade to the right to represent all of the numbers that are close to negative 3 but not exactly negative 3, and greater all work in that original inequality. Okay, so that's example 1. Let's go on to 2. All right, so example number 2, let's distribute that 7 minus 35k minus 6k is greater than or equal to a negative 280. Next, ask yourself, is there any terms that are common that you can combine? And the answer is yes, because we have 2 terms on the same side of the inequality that have the same variable of k. So when we combine those two, we then have 7 minus 41k is greater than or equal to a negative 280. Cool, okay, so now let's subtract the 7 to the other side. And we have negative 41k is greater than or equal to a negative 287. And then the last step, let's divide by negative 41, divide by negative 41, divide by negative 41. And because we're dividing by a negative, we flip that inequality, and k is less than or equal to a positive 7. All right, so let's go ahead and draw our number line. 7 is in the center. To the right, we're getting larger, so it's 8. To the left, we're getting smaller, which is 6. This is a closed dot, right, guys? Because it is equal to. And since k is everything less than 7, we want to shade to the left, everything that is less than 7. Okay, so here is my favorite part where you get to try it on your own. And here it is. What I'd like you to do is to pause this video and attempt this problem and then press play when you're ready. Okay, here we go. Hopefully you didn't fall into that trap we talked about on the first problem. You want to distribute that 8. You do not add 8 plus 1. Note. And then we have 345 is less than or equal to 1 plus 8 plus 56k. Okay, so now then from there, you would want to combine your like terms. So we have 1 plus the 8, which is 9. So we have 345 is less than or equal to 9 plus 56k. And let's subtract that 9 to the other side. Great work. All right, so now we have 336 is less than or equal to 56k. And when we divide by 56, no negatives for this problem. We just have that k is greater than or equal to 6. I'm interested, did any of you flip it around? That k and then you turn the inequality so it faces it, 6. Yeah, cool. And then from there, when you draw your number line, 6 is in the center. Let's represent 1 to the right, which is getting greater, 7. And then we're getting smaller to the left, which is 5. And we have a closed dot on 6. And all of the numbers that are greater than 6 will work in this inequality. All right, guys, I hope that you've enjoyed this week of learning of inequalities. I miss you in the classroom, and I hope you guys have a good week. All right, see you later. Oh, don't forget to like the videos. Okay, cool. Bye.